So we set up our initial model by placing two candles in two different containers, one that had water in it, one that did not. We were trying to figure out what would happen when the candle went out and why. And so in order to do that, we lit both candles and put two different containers over each candle to see what would happen.
And when we did this, we predicted that both candles would go out when the jars were placed over them. We thought that the jar that was in the base with water would go out first because there's less airspace, and there was less oxygen available since there was less airspace. So the water's already out, and then that one just went out. For the second step, we did collecting new data, and we basically just repeated the experiment, but we looked more closely and made more observations, and it was this time that we saw that the water level was rising. That went out really soon.
Look at the water. Look at the water rise.
Yeah.
It seems like the water rose after the
After collecting our new data, we wanted to revise our model, and we wanted to take a closer look to see the significance of the size of the jar. So we used a larger jar, which allowed us to observe closer if the level of the water was indeed rising.
It rises really steadily at first. And then
it gets quicker. See, it was rising when it was burning, but then once it started to die, it just got really quick,
Okay, so our next step was evaluating the model, and in this we looked at what is the difference between the base with water and the base without, and how is our model helping us understand this. So our original theory was that the candle would go out because the oxygen was being used up, and so once we put the jar over it, that the oxygen eventually would go out, right, and the candle would go out. And then we realized that the water level was rising, which I don't think anyone predicted, and we had to do more close observations, and we did see that the water level was rising, and I think that the model was really good at showing that. So at that point, we brought in our background knowledge of why a liquid would rise in some situation, and somebody knew that could be caused by a vacuum, and so then we hypothesized that it was because a vacuum was being created when the oxygen was being burned up, which is true. I don't think that the model actually showed that. It was just kind of based on our prior knowledge. So in that instance, then we would say that the model wasn't that good at showing the creation of a vacuum.
It just showed that there was something happening that was causing it.
Right, it showed the effect, but if we did not have that background knowledge, then I don't think we would have come up with the vacuum idea.
So we wanted to generalize our model to other situations and see how it would affect it if you slightly altered. So we used a big jar and a little jar in the same base of water, and so we wanted to see which one would extinguish faster to see if that our idea of the air inside of it having a huge impact, to see how it would change and affect in this situation. So we lit both candles and put a bigger jar and a smaller jar, and we saw that the water level rose, and obviously in both jars, but it was the bigger jar took longer, which we saw was probably based on the fact that there was more oxygen inside, so it took longer for the oxygen to be converted to carbon dioxide and to be used up, and so therefore it took longer and it had more water in the larger jar because of it was created a larger vacuum.
2, 3. This one's out, and the water level is rising. Ooh, that might be cool.
Okay, so to wrap it up, by going through these 5 stages of inquiry, we're really able to collect the data through first-hand observations, then to revise our model, collect even more data, and then generalize our hypothesis to new situations and see how it applies.